friends. Today we are going to learn about the Einstein theory of relativistic mass. Assuming that you have a general idea of dynamics of rotational motion and relativistic mass theory, let us head into this session without any further ado. First of all, the expression for Einstein theory of relativistic mass is m equals m naught divided by root of 1 minus v square by c square, where m is the mass of the moving object, m naught is the mass of the object at rest, v is the velocity of the object, and c is the velocity of light, which is given by 3 into 10 power 8 meter per second. For the first time when we came across this formula, I'm sure all of you would have been wondering, how is the mass of the moving object different from the mass of the object which is at rest? Because we have always learned that mass is the amount of matter that is stored in our body which remains constant regardless of where we are. But Einstein's theory goes to say that the mass of the moving object is different from the mass of the body which is at rest, which is in contrast to Newtonian mechanics, which says that the mass of the moving object is same as the mass of the object which is at rest. Mass in Einstein theory is of two types. Firstly, invariant mass or rest mass. Secondly, relativistic mass. First of all, let's discuss about invariant mass or rest mass. Invariant mass or the rest mass, as the word denotes, it is the mass of the body which is at rest. That is, to find out the mass m naught, which is the rest mass of the body. Invariant mass or rest mass differs from relativistic mass by this single word, that is, frame of reference. If the frame of reference is taken to be the same, the value of rest mass will be the same as the relativistic mass. So you might be wondering, what does frame of reference actually refer to? Frame of reference. It would be better if I could explain frame of reference with this small concept. Let us consider two passengers. This is passenger A, who is traveling in a train moving at a speed of 50 meters per second. That's kind of slow, it's alright. And we have another passenger B who is standing at the platform waiting for the train. Both these passengers are in different frames of reference. To passenger B, it appears as though passenger A is moving at a speed of 50 meters per second. For passenger A, since he is already seated in the train which is moving at a speed of 50 meters per second, he feels as though passenger B is moving in the opposite direction at 50 meters per second. Thus, it is the different frames of reference which they are in which makes them view at the other person moving at different or opposite velocities. This is what we call as frame of reference, and this is the frame of reference which is causing the difference in the rest mass and relativistic mass. Now that you've understood what is meant by a frame of reference, it is a frame of reference which is making the difference in the rest mass and relativistic mass. To be precise, it is the frame of reference in which the center of momentum is taken into account in the calculation of rest mass, whereas in relativistic mass, the frame of reference is not composed of the center of momentum. So, which makes the need for me to explain what is meant by the center of momentum. As I mentioned in the beginning of the session, as you would have had an idea of rotational motion and the concept of center of mass. Center of mass, it can be defined as the point in a body at which the entire mass of the system is meant to be concentrated. In actual, the mass of a body cannot be concentrated at a single point, but we assume a center of mass for a system for problem solving and for conceptual purposes. There are several pairs of forces acting on the center of mass and on every other point in the system. But the center of mass is the point at which all the pairs of forces which is acting on it gets cancelled. And if a force is going to be subjected to this point from an external force Fe for instance, if it's going to be subjected to the point called the center of mass, it will move as though it is a single point and it will not be subjected to rotational motion. Whereas if this force is going to be applied to any other point, it will be subjected to rotational motion. So this point is termed as the center of mass. The center of mass is calculated by this expression summation MI/RI divided by summation MI. So now that you've had an idea of what is a center of mass, I think it would be better for me to explain what is meant by the center of momentum, which is making the key difference in the different values that we obtain in rest mass and relativistic mass calculations. It is given by the expression summation MI/VI divided by summation MI, where momentum rho equals mv. M is the mass of the body and v is the velocity of the body. So the invariant mass is calculated from the frame of reference, which consists of the center of momentum. At the center of momentum, the total momentum vanishes. It is an inertial frame of reference. Hence, in the calculation of the rest mass, it's only equal to the mass of the object at rest. But in the relativistic mass, the calculation involves the mass of the object plus the kinetic energy of the system. Might be wondering, where does the need for the kinetic energy of the system arises? Because in relativistic mass, the frame of reference differs. In a rest mass, the frame of reference is not at all taken into consideration, but in a relativistic mass, we have to take the consideration of the frame of reference. And also, because the frame of reference does not consist of the center of momentum, it is not an inertial frame of reference. It has different momentum, and that momentum has to be taken into consideration. And the formula which is used to calculate the kinetic energy of the system from the momentum of the frame of reference from which it's calculated is given by Ek equals P square by 2m, where P is the momentum, m is the mass, and Ek is the kinetic energy of the system. From this, the relativistic mass of the system can be calculated. Relativistic mass is the total energy of the system, and total energy of the system comprises of the measurable inertia. Inertia is the amount of resistance that the body offers to the change in velocity, or sometimes called as momentum, and that is the reason why we have to use the momentum to calculate the kinetic energy and substitute it to calculate the relativistic mass. How can mass be added to kinetic energy? Well, the mass has to be converted, and that is a famous relation given by Einstein, E equals mc square, and by substituting the mass we can find the energy, and when these two energies are calculated and added up, we will get the relativistic energy. So guys, today we saw about the Einstein theory of relativistic mass, the formula m equals m naught divided by root of 1 minus v square by c square, The two different types of masses, invariant mass, relativistic mass, and how they differ in terms of their frames of reference, the center of momentum which is taken into consideration in the case of rest mass, and how any other frame of reference other than the center of momentum is calculated for relativistic mass, and the formulas which are applied for the calculation of rest energy and relativistic energy. Thank you.